And we're live.
We are live again. So, hi and welcome everyone. Thanks for joining our Terramate Office Hour, and it's already volume 3 in 2024. And as you might have seen in today's session, it's all about Terragrunt and how to import your Terragrunt projects to Terramate. And next to me, it's Søren Matzius, who will showcase this in today's live demo. And also at the end of today's session, we will have another Q&A to, of course, to make sure to answer all your questions. So, Søren, is there anything to add before we shall get
You
started?
did very well. You did very well. Thank you so
Thank
much.
you.
I think we slightly changed the format. Great. Thank you so much, Selina.
You're
And
welcome.
it's already dark here in Berlin. Yeah, once a time. We're both in Germany today, not
Mm,
dialing in from California. So, guys, thank you so much for making it to the session. We have an exciting topic today. I think with Terramate CLI, we recently shipped Terragrunt integration, and we have a pretty good demo prepared for you today. So yeah, topic of today's office hour. Thanks for joining. How can you integrate Terramate with Terragrunt? And the question is, why should you care? Yeah. So I think there's like a bigger story to it. So quite often when, we talk to people about Terramate, they're like, oh, but I'm using Terragrant already. So now in order to leverage functionality in Terramate, do I need to replace whatever I have already? And I'm like, no. So actually, the main goal, or one of the main goals when we designed Terramate, is to integrate with all existing tooling in a non-intrusive way. And the way that we think about it is that, you know what, if you already have Terragrant and you already have an existing Terragrant project, that's great. But Terragrant comes with one major disadvantage. And the disadvantage is that typically in Terragrant projects, you can either execute all modules with Terragrant, apply all, I think it is, or run all apply, or Terragrant apply to, or plan or destroy to execute in a single module. And there's like no easy way to figure out what modules actually contain changes, and there's no orchestration of commands. So the way that Terramate works here is that we thought, how can we help our users to overcome those issues and also open up a potentially broader audience for Terramate, right? So we do this by seamlessly integrating with Terragrant. And the reasoning for that is, and what's for you on the table is, so basically we'll show you how to run change detection in Terragrant projects, how to onboard them with a single command, really without adding or changing any existing configuration. And then also two, of course, that integrates very well with Terramate Cloud, which will probably not be the center of the conversation today, but it means that you could use Terragrant projects to push stacks insights of the observability data, collaboration, and whatnot to Terramate Cloud for better insights. Let's dive right in. And as always, I'd love you guys to to be a little bit patient with questions until the end. More than happy to take the last 15 minutes. So we've 1 hour scheduled, and to basically focus on questions during the last 50 minutes. And hopefully the Terraform applies won't take too long, so we can also get somewhere with this. So what we will be using today is this Terragrant infrastructure live example. Luckily, Gruntwork has issued an excellent reference architecture here for Terragrant. And I basically want to show you how, yeah, we can leverage this and basically try out Terramate in a more real-world example without starting from scratch. So let's do that. I'm gonna start by simply cloning the repository. So let me do this. I'm gonna run a clone command here, git clone, and then I will cd in this directory and open VS Code. so you guys can follow what I do too. So what you can see here is that I basically have this reference architecture clone open in VS Code, and then it comes with two different environments, right? Prod as well as non-prod. We have some common files here in Terragrunt that are basically used to share inputs and whatnot throughout modules to keep them dry. So it's a Terragrunt specific context. So now I can run Terragrunt in here. Let me see if I have this installed. Terragrunt is installed, and let's see what Terramate version I have installed here. Terramate version 0.50. So let me do something. Terramate local. Terragrunt latest. Just gonna set my package manager here to use the latest Terragrunt version. I'm gonna do the same with Terramate. So let's just ensure that we're on the latest Terramate 0.53. That is great because that includes the change detection and the orchestration for Terragrunt. So now this is a native Terragrunt project, and we could basically start here by running commands such as Terragrunt apply and whatnot. But I really want to showcase how to do this with Terramate to get more performance out of our projects. So what I'm doing is to basically set this up as a Terramate compatible project. Is I'm gonna just create a slide configuration file in here, and then I'm gonna add some content here. So what you can see is that basically what happened is I created this terramate.tm.htl, and I basically put a configuration here which declares this specific project as a Terramate project next to being a Terragrunt project too. So what I'm saying is that the the Terramate extension and integration is still experimental, so I need to explicitly enable it in our project. And I also say, hey, the default remote of this repository is origin, which is also configured by default, but the default branch is master because Terramate always assumes that the default branch is main. Which is sort of a newer standard if you work on GitHub. I also disabled a bunch of safeguards here. So why are those safeguards essential if you work in a production environment? Because it basically prevents you to run Terraform commands and Terramate stacks without having all files checked in or without having all files committed or pushed to the remote branch. So by that, we make sure that if I was to run something locally, I basically it basically directly reflects whatever we manage in our remote branch. And it's just an extra safeguard to prevent stupid mistakes to be executed locally. One could argue that quite often it should not be required to run Terraform locally anyways, because you usually go through a CI/CD. So what next? For me to onboard Terramate to this existing Terragrunt project, what I can do is I can say Terramate create all Terragrunt. Let's try this out. So what is happening here? Terramate basically scans for Terragrunt modules. And you can see here that it found this non-prod US East 1, QA, MySQL, and the web server cluster. The same for the staging environment, which is in the same account. And then in the production account, it also found the MySQL stack and the web server cluster. Great. Okay. If we look at our Git, what has happened is that basically Terramate looks into those modules and it looks for Terragrunt configuration, and then it just creates a stack for us. And the stack in Terramate is always identifiable by adding a stack.tm.htl. So what does it mean is, what this means is that basically we don't touch any existing configuration here in order to onboard Terramate. In fact, we don't touch any part of your Terragrunt project. So if we think about this a little bit more, that also means for us to really offboard Terramate again here, let's say you decide to not use this for whatever reason, you can basically just create those stack.dm.hcl files and you end up being in native Terragrunt environment again. And it's very important to understand because usually, if you decide on tooling, it's like, yeah, but then I need to migrate 6 months from Terragrunt to Terramate, and it costs so much money and pain, and our developers need to learn a tool. No, this is not the case. So we integrate in a non-intrusive manner. That is our goal for all other environments, all other tooling that we will integrate in the future with too. So let me do the following. Now that we have Terramate onboarded, we can basically show a list of all Terramate stacks. Let me do this. So Terramate list, executing Terramate list here, basically says, hey, this is the list of stacks that I have found. I can also say list stacks changed. We'll use this a little bit later to understand what stacks contain changes in the latest commit, branch, or pull request. And that's essential because by using the change detection, the change flag that is now integrated with Terragrunt, we can essentially filter Terragrunt modules to execute Terragrunt apply in Terragrunt modules that contain changes only. Let's do a little exercise here. So I know that in order for me to make this work, I need to actually touch a bunch of Terragrunt files. So I think for today, maybe we focus on this prod account here. And Terragrunt basically, so this reference architecture provided by Gruntworks requires me to reset these, this replace me placeholder here with an actual AWS account ID. So I'm just going to do that with one of my personal accounts. And I think now we should be relatively good to go. Also, too, I'm using a tool called AWS Vault connected to 1Password here in order to query my AWS credentials locally. So let me sign in to 1Password on the CLI. This worked. We clear the terminal. And now we say AWS exec. My profile here is Terramate Soren. And what we want to do is we want to say, hey, Terramate run to orchestrate a command in stacks and do this in prod. And for example, what I can say now is I can say, hey, instead of running Terragrunt apply, just run pwd. So this will ask me for another password to basically use AWS Vault. And what you can see here is that Terramate run basically detects those two stacks, right? And it basically changed space inside those stacks and runs the command pwd. So if we were to update this non-prod environment here to the same account ID too, let's do this. And I just run Terramate run without this change of directory. Now what we can see is Terramate detects all stacks. It detects the stacks in the non-prod environment, which in theory should be a separate AWS account, I assume. And in production, which again, those accounts should be separated, but I only really have one account accessible now, so we focus on that. Right, so how about running a plan? Let's do this. Let's say, hey, you know what, Terramate run, and we want to run this in prod. And now, so we say, hey, Terramate run in all stacks that you find within this prod directory, run Terragrunt plan. Let's see what's gonna happen. Oh, I actually think it will fail because first we need to run an init. But let's see what happens here. State bucket is missing. Interesting. So let's not do this for now. What you can see here is Terragrunt basically requires us to set up the state bucket. And I can see that the state bucket configuration here is still set to the default name. So I want to go in the Terragrunt configuration and update this to something unique because bucket names in AWS are unique among the entire AWS namespace, so global namespace. So I'm pretty sure office hours, I'm pretty sure this bucket name is already taken. Let's do this once again. And then we run Terragrunt, I think, probably init. So would you like Terragrunt to create the S3 bucket for you? Yeah, great. Let's do this. Okay. So now what I'm doing essentially is orchestrating Terragrunt with Terramate, and Terragrunt basically asked me up on creation here to create this missing state bucket for me because we persist our Terraform state in S3. So this has worked. Great. What next? So if we look here at this hierarchy in Terragrunt, we can basically see, okay, so we're on prod, then they use the region here, US East 1, and then they have 2 stacks here. Yeah. So the Terramate orchestration will detect and resolve dependencies among Terragrunt modules. So if we were to share outputs here, common pattern in Terragrunt, and we run and we use the Terramate orchestration, it basically detects those. However, let's do the same in all stacks for now. Terragrunt init and see what's happening. So this will also actually, let's focus on this one environment. Otherwise, we need to create two state buckets. Prod. Let's run the plan. Now that we've run the init, let's run the plan and see what happens here. So in theory, this should detect those 2 Terragrunt stacks. Interestingly enough, it asked me for a password for the database on the CLI. So I'll just put something here. Normally, you would probably pass this either as an environment variable or with a secret manager, vault, or whatnot. And we can see, so what Terramate is doing here, basically Terramate orchestrates Terragrunt plan in its first module, right? Which results in a plan. And then it goes into the second module and it runs the plan in there. So let's do the following. Let's apply this, and then we can talk a little bit because this will probably take a little bit of time. So the common pattern that you guys will be used to is, I think, Terragrunt run all apply or apply all. I'm not sure. Let me actually check this, look this up. Terragrunt apply all. Run all apply. Okay, you are probably used to running this command here. Terragrunt run all apply. The problem with this is that, as the name says, you will always run this on the entire Terragrunt project. So what we really want is we basically want to use Terramate to run either Terragrunt plan or apply in specific stacks, or by using the change detection, which we do with the change flag here, to only invoke this command in stacks that actually contain changes, right? So let's do this. Terramate run in the production environment, Terragrunt apply. This will perhaps ask me for the password again. Yeah. All right. Do you want to perform this action? So let's look at the plan here. So it basically detected the MySQL instance stack first to deploy this, and then it will take the web server cluster. So let's do this. Let's deploy an MySQL instance on AWS. I haven't used MySQL in, yes, really, in, I don't know, 5 years or so. It's only ever Postgres, if it's a relational database, or mostly. Anyways, that's a different topic. So as we can see here, basically we use Terragrunt now to apply this module. And it's going to take a little minute. Probably more something like 5 minutes or not. Well, I can look at the configuration here. So what they do here in this specific module to keep it dry, to basically say, hey, do not do not configure all inputs here, just the specific inputs for this environment. So this is database of the T2 and then 100 gig of storage. But the basic input parameters, they basically pull from this shared mysql.htl, which is in this env common directory, and then they basically override on a per stack basis whatever they want to update here. Yeah. It's a little bit different in how we think about it in Terramate. I think um the way that configuration in Terramate works is there really are different patterns. But one pattern is specifically in code generation is global. So well, this is a good approach here. I actually used this for some time myself, long before we started Terramate. I think the one way that we want to do different, where we are pretty opinionated, is that we don't want to abstract away Terraform for you in a sense that you move from a native out of a native Terraform environment. Quite the opposite. So the in-strict motivation of Terramate was always to focus on allowing developers to stay in a native environment, hence the code generation. And code generation in Terramate comes with a bunch of features. The way the database is still deploying here, can pull this a little bit up and talk a little bit more about the code generation. The way the code generation works is that you basically generate native Terraform code at build time, not at runtime. So you would come up with a bunch of templates, for example, to deploy, to generate backend configuration, Terraform configuration inside your Terramate stacks. And then when you run Terramate generate, it basically creates native code for you. So why we think this is great, because it basically allows you to execute all third-party tooling inside your stacks. So for example, and we've written a blog post on this a couple of weeks ago, really. So Terramate stacks as their native Terraform or OpenTofu environments, really, you can run InfraCost in those, right? You can run Checkov in those, TFSec, TerraScan, and whatnot. And also we're not a CI/CD platform, right? So what you can use Terramate to run the orchestration in any CI/CD. So to reuse GitHub Actions, GitLab pipelines, Bitbucket, Azure DevOps, you name it. Which, by the way, I see a big trend going toward big GitHub Actions. My personal opinion is that most likely people will buy purpose-built CI/CDs less and less and sort of consolidate their stack on GitHub Actions or whatever they have already. But it's a whole different question. So again, the Terramate, especially in the cloud, we don't really focus on CI/CD. Instead, we give you the tools to integrate with any CI/CD that you have already. Even if that's a purpose-built, you can perfectly use Terramate stacks in there to deploy a bunch of infrastructure with infrastructure code. It's unbelievable how long it takes to deploy a single and small MySQL instance on AWS. But it is what it is, and my previous test shown me that it will probably take somewhat around 5 to 6 minutes. So I'll just keep talking. That's what I enjoy. Kidding. So once we see the stack finishing here, right? What should happen is that the orchestration should jump from the MySQL Terragrunt module or stack to this web server cluster, right? Which basically is, I think, an auto-scaling group of EC2 instances, if I'm not mistaken, and deploy those. So now we can see MySQL ran through. So this worked, and this only took 5 minutes. It's actually not too bad, taking into consideration that we just deployed an end-to-end managed database. I'm pretty sure this can be fast on some platforms, but it's not too bad. And now what we can see is like, oh, you know what? Terramate entering stack in prod US East 1, prod web server cluster, and now it executes it executes a Terragrunt apply here. So this will a Terragrunt apply, yes. So this will first give me the plan. And what we can see here is that basically it reads a bunch of default data sources here, I think. Yeah. To query the so data sources to query the default VPC and subnetwork in AWS to then deploy this AWS autoscaling group in there. And let's do this. And what else does it do? It deploys a load balancer, few load balancer listener rules, whatnot. Okay. Apply. Let's do this. So, will be interesting to see how long this will take. And after completion of this, we can look into, so this is this is initial rollout, day 0, and day 0, initial rollout of the infrastructure. And after this, we basically want to introduce a change, but but in a stack that contain changes only, right? So day 1 is finished any minute here. Hopefully. So let's wait. Still creating. I remember the one time I deployed an complex EKS cluster with multiple node pools and stuff, and it like took an hour or so, and then it fades like 50 minutes in because of some misconfiguration. Terrible experience. But it is what it is. Creation complete after 1 minute and 40 seconds. So this is the autoscaling group. And now it's still creating the load balancer. So let's wait for this too. In the meantime, let's fold this back here a little bit. Focus on getting the essential rights. Hopefully load balancer will be done too as well. And yeah, so what's next? Now that we initially rolled out this infrastructure, what we want to learn is, so that's great, right? But that's not of too much benefit because honestly, you would just have run all apply anyways to roll it out. But how about I am to introduce a change to a stack, right? And only to one specific stack. So this is where the challenge occurs. And traditionally, people try to build around this by having manual workflow triggers and GitHub Actions pipeline to specify input parameters for whatever module they want to deploy and whatnot. But the way that the change detection works here, and we'll see this once this load balancer is deployed, it's just completed now. And the way that the change detection works is that it basically allows us to filter this for us. Great. So we're done. We successfully run Terragrunt apply on everything that is inside this prod folder here, prod directory here. Great. So surprisingly easy. So now what's next? I already mentioned Terramate list gives us a list of all stacks. Yeah. With Terramate list, we can also say, hey, you know what? Only show me stacks that are located within this prod directory here. So then it would of course only detect those 2 stacks. Let's look at our Git status here. It's a bunch of files. So what has happened? We, first of all, modified a bunch of files. We set the account ID here in basically both environments. Then we edited the Terragrunt configuration to use a Unix state bucket, which was also created for us. And we added a bunch of Terramate specific configuration here, basically just stacks. So let me do the following. git add all commit feed awesome Terramate Office Hour demo. So I'm just committing this to my local environment. I haven't forked the branch. I just committed it. So if I now say terminate list, it will show me all the stacks. If I say changed, then it will basically show me what are the stacks that are changed in the recent commit from this commit. Yeah. So now what I can do here is I basically want to create a new office hours, create a new branch. So typically, if you were to introduce a bunch of changes following a GitHub flow, you'd always create a new branch, right? Let's do this. So we create a new branch, office hours. Let's also to touch one of those stacks here. For example, let's take this MySQL stack and allocate a little bit more storage, 120 gig, and hopefully this will work. And now what we can see is, so basically git status, there's a changed file, git add prod, git commit. Now we say, hey, scale up the awesome database to 120 gig. So we do that. Now introduce the change. Now what? So if we were to work in a collaborative manner, probably would open a P and some sort of automation would run, but I'm just gonna do this locally now. Basically, what I can say is I can say, hey, Terramate list changed. Yeah. So give me a list of all stacks that contain changes. And as the change base, use the most recent commit. So now what Terramate will do is it will look at this commit that I just introduced here, and it will detect what stacks contain changes inside this commit. And as you can see, if I go back to git checkout master, and I run this command, it will basically show me, hey, you know what? On the master branch in the recent commit, you changed all stacks, which is what I did because I onboarded Terramate to those stacks, right? So they are targeted as changed. But if I go back to the office hours branch and I run this command in here, it will basically only show me this stack. So now, how can I use the change detection to basically invoke Terraform, Terragrunt commands, infra-cross, like really any command? I can say, okay, you know what? I need AWS Vault here to use my AWS credentials, Terramate Soren, great profile name. So Terramate run Terramate orchestration on the prod directory only on change stacks that have changed within the last commit, and run pwd inside those stacks. AWS Vault asked me for my password. I always forget about it. Git, there's a typo here. Git change base. This will work. So now what Terramate does is, oh, you know what, right? I have this list of, I don't know, 1, 2, 3, 4, 5, 6 stacks here, right? But by basically saying, hey, only change stacks and only within the last commit, so we can also provide a range of commits here or a different branch to compare changes between one branch and another. That's really up to you. So by default, it's always the latest commit, by the way, to the main branch. I can say invoke Terragrunt plan only on this specific module. And that's what I'm doing now. And now what you can see is, so Terramate is entering the stack and prod US East 1, prod MySQL. And it basically provides me with this plan of the changed storage. Great. So now, how about I introduce a change not only to the MySQL, but also to the web server. I can, of course, do that and say, okay, let's scale this down to minimum. Scale this down to 2 instances. So min instance size 2, max instance size 2 should effectively scale it down. And now I can either add a new commit and then compare on a range of commit, or I'm just saying, you know what? I'm just gonna amend this to my previous commit. So now if I run terramate list changed get change base head, you can see that both of those stacks are targeted as changed. And that's because the change detection in terramate basically heavily leverages Git, right? And it uses Git to understand, hey, do those stacks contain any changes? Not only that, though, the change detection also too has different integrations. I think in a previous session we discussed that Terraform is one of the integrations. So effectively, Terramate will detect stacks if changed if any of the reference modules contain changes without you ever touching the stack, right? So it has deep a deep change detection in the sense of that it also looks at the underlying modules, and the same for Terragrunt, right? And it also respects dependencies in Terragrunt. So that's really great. So let's now do the following. We roll this out. So we say, instead of running the plan, we run apply here. So we run, hey, you know what, termate run in the production environment. Again, in theory, I could run this on the entire project, but I didn't think rolling out 3 different databases would eat up the whole office hour. So we keep it to one environment for now. And basically do this on only stacks that contain changes, and now run Terragrunt apply. So the password for the database is this. And now you can see, aha, it allocates a little more storage. That's the configuration that I just adjusted. So what else while this is running? Now, and then we're slightly running out of time also. So of course you can use the orchestration here, the change detection, but also too, you can push this data to Terramate Cloud, right? We already said that the way that we already discussed this in an earlier session, the way that the data sync between CLI and cloud works is that basically Terramate looks up your modules here and it looks like, oh, how do my resources look inside those stacks, etc. And then it syncs this to the cloud. I unfortunately think we don't have much more time to set this up. But for you to understand how this would look like, I'll see if I can get this over here. Let's see. So cloud.terramate.io. Let's use this Terramate demo organization here. It's actually already opened here. So the way that this works is that basically Terramate Cloud, it shows you deployments and stacks and whatnot, right? So this is a different repository here. It's not the repository we just demoed. But then essentially it gives you an overview. So it syncs data from the CLI to the cloud. And it shows like, oh, are there any stacks that are drifted, right? Drift detection, the actual compute part runs in any CI/CD. So we never see your state. We never see your credentials. In fact, Terramate Cloud never has access to any of your sensitive data. But if we look in here, we can, for example, see, oh, this is a Terramate stack, right? So now this could be a Terragrunt stack, of course. The stack passed a unique ID when it was last deployed, the latest drift runs, etc. And then of course also, so there's a little bit more functionality than this, but here, for example, this is a stack that is drifted, and we see the reason for this drift here. Let's jump back to the CLI, and we can see it will also scale down the web server next. So I could also, of course, hand in auto approve here as an actually argument, something like this, auto approve. But I don't like this much, to be honest. I'd like to review my changes before I roll them out. And now we have everything deployed within this specific environment with Terragrunt and Terramate, right? So if we were to say, hey, you know what? Let's only change the production database down again. We go in here, change this to 120, and then we basically run the same command again. If you want to see first what stacks contain changes, so let's add this to git add, just amending my latest commit here for now. Terramate list changed. And then you see, oh, I only changed this specific module now. So this is more or less how you can work with Terramate and Terragrunt. And now the nice thing is, so if we were to, decide, oh, you know what, it's not for me, then all you need to do is you go in here, you delete this terramate.tm.htl, you delete those stack.tm.htl, and bam, you're back in a native Terragrunt environment, and effectively you never touched any of your existing configuration. So now, if I was to do that, I can basically say AWS Vault, exec, here are my credentials, and now Terragrunt run all apply or destroy. But of course, the downside here is that it would always run on my entire project. That's it for today. I think we're at the 45-minute threshold. So to recap, what have we learned today? Terramate can be onboarded with a single command, which is really the Terramate create all Terragrunt in existing projects. So what this does is it basically scans for Terragrunt modules and onboards Terragrunt in there by adding the stack.tm.htl, which is a configuration file required to mark a directory as a stack in Terramate. Terramate is, by the way, also infrastructure as code agnostic, so stack could contain Terraform, OpenTofu, Pulumi, we don't really care. And it has a bunch of configuration options like name, description, ID, but also orchestration behavior can be configured here, which is a little bit more of an advanced pattern. We also learned to use the Terramate commands list to basically get a list of all stacks, to understand what of those have changed by using the change detection. So you could also just append the changed argument here, and it would per default compare to back to the main branch or master branch in this case. And we learn how to use the orchestration to not run Terragrunt apply all, but just Terragrunt apply on stacks that contain changes. And now we're more than happy to stop sharing my screen and answer all your questions.
There's been a little conversation going on LinkedIn. Jonathan asked, but Marius, our co-founder, already answered. He also jumped on.
Interesting. So let's look at this a little bit. So Jonathan, thanks for your question. Let's see what the actual question is. So we have a bunch of questions here, really. And thanks for jumping in, Marius. So the way that the change detection works is not only by comparing, and I tried to mention this earlier, not only by comparing whatever stacks contain changes, but it also has integrations for, or it has several integrations. So the way that we designed the change detection is that it's fully extendable. Right now, we have integrations for example, Terraform and then OpenTofu and then Terragrunt, and those all have specific behavior. And it basically allows you to solve specific use cases. So I mentioned already that in Terraform, typically if you change a local reference to a module without using versioning or whatnot, you probably want to mark a stack as changed, even though a stack does not contain any changes in the actual directory. So that is what those kind of like special behaviors is what the change detection does. And it's something that does not exist natively in Terragrunt. Like even though Terragrunt is a really decent tool, um, I think adding orchestration and change detection here can like specifically speed it up a lot. Yeah. Um, and then it also directly relates to like, oh, order of execution and those kind of things. So I think as Marius mentioned here in this specific comment already also too, it is an experimental feature. It works pretty well. So we not only tested this on small infrastructure, but then also really big one. And it well works as expected. And I think what's particularly exciting is that you can start using this and start using Terramate in whatever you have already. So add value without much migration effort. Yeah. So many. Let's see. Um, Interesting. Okay, let's look at the other channels. Um, so does that respect dependencies too? Yes, it does. So I just saw this now. It respects dependencies. And so the way that orchestration in Terramate works is, so Terramate has its own order of execution. We can specifically, so there's a default order of execution, which basically says we follow similar patterns than sorting, ordering in the directory tree, but also to the file hierarchy. So if we let me quickly share my screen once again. So basically, if we look here, um, if we look here at the directory tree, so those kind of modules here, if they were independent, they would just execute sequentially, following ordering similarly to the file ordering in your directory tree in your file tree. If they're nested, then the parental stack would be executed before the nested stack on any level. But those kind of default behaviors can also be overwritten. So there is a decent documentation on that. And by the way, we're working very, very hard on relaunching our documentation to make it a lot more use case specific and also a lot more complete. So we had a bunch of people asking for this basically in Discord and all other communities after. But basically, stacks can be configured. So I mentioned that already. Let's look here at the docs. So basically, we can explicitly set the order of execution in Terramate orchestration using in stacks using configuration such as after, for example. Yeah? So after defines a list of stacks that this stack must run after. So effectively, what I define here executes before my current stack, right? And I can either define a path or I can also use tags. Right? Stacks, by the way, can contain stacks too. It's something, so stack creation stuff we haven't really discussed today. It's more about how we onboard this in Terragrunt environments. But yeah, order of execution behavior, and also things such as force execution, triggers, those kind of things can all be configured and also respected, of course, if you use Terramate orchestration in Terragrunt projects. Good. So I don't think, are you able to detect if stacks have changed? Yes. Yes. So um, that's a very good question, actually. It's also coming from Jonathan. Jonathan, let's answer this quickly too. So are we able to detect a stack as changed if a common or centralized, so what we showed configuration, it does not it is not located within a Terragrunt module but outside and then loaded inside of this module, will this trigger, if we modify this, will this trigger a stack as changed or potentially a number of stacks as changed? Yes, it does. Is the short answer. The long answer is that we basically look at the functions used by Terragrunt here to understand the semantics a little better. Selina, do we have anything else?
I think this is it for now. Let me have a check again. But I think you almost answered everything, and also Marius did. If there are no more comments or questions.
Awesome. Well, I'm gonna be at KubeCon in Paris next week, or we will be in KubeCon at Paris next week. If anybody wants to meet in person or so, we'll not have an office hour next week because of that. I think sort of at least half of the industry is there. But I'd love to connect in person. You guys probably also seen that we run a platform engineering dinner on Monday. It's a good Italian restaurant. So if you're there, I'd love you guys to join. We still have some more spots opened. Just feel free to ping Selina here or reply to, just send us a message on LinkedIn or whatnot. Yeah, it's easy.
Yes.
And other than that, we'll be back with the next office hour in 2 weeks. I'll be back in California by then. So this will be 10 a.m. PT and then 7 p.m. Berlin time. Thank you so much for dialing in. Thank you, Selina, for guiding us
You're
through.
welcome.
It was great, and I love your new microphone. It's awesome.
Thanks. So
And
much better.
yeah, we'll share a blog article on what we have discussed in more detail and also with the cloud integration, etc. Later this week or latest early next week. So step-by-step guide on how to get up and running with Terragrunt and Terramate. And I'm wishing you guys an awesome morning or evening or wherever you are in the world right now. Bye bye.
Bye bye.